So I think the first topic we have on here is about the host cache objects. It's basically just this tracker here. Essentially, we have an issue with the host cache objects getting too big. To give a little bit of background, when they gather a lot of info on a host, like the disk they're using, various other facts, we put it all into one big object, a Python object, and then when we want to store it, in case of like a manager failover or anything, we put into a big JSON object we stored in the Monkey store. The problem is the Monkey store has a default size of 56K for a maximum. And so occasionally, if we have a really dense host that has a lot of disks on it or something, we can actually overflow that size. And when that happens, there's just some sort of background failures that happen because we can't store the information about the host cache. So there is a workaround for this. You can just increase that minimum and then it works. But what I remember sort of fails in the background, and it's it's not a nice failure because then you just sort of lose information on the host. Well, it would be nice if we could sort of handle this graciously and maybe not overflow it to begin with. Although it's kind of a tricky one because ideally we don't really want to like split up the host cache into a bunch of different objects. So yeah, it's kind of hard. So the idea that I sort of had is that because I think devices are the main thing that would be causing the overflow, I think the biggest thing on there is that maybe we could split up into sort of a separate device cache. And if we have a device cache and a host cache, the host cache just stores the other things, and device cache is sort of a different object. And the device cache, I think, would be easier to split up than the host cache objects. If we did it that way, I think we could maybe just avoid this overflow. Obviously, there would still be some way which it would be possible, but it would be considerably less likely. You'd have to have a lot of stuff on one host in order for that to happen. So that was my sort of only idea I've come up with so far, sort of avoid it nicely. Other than just, I guess, having clear error messages. I don't think we should be touching the size ourselves. Maybe we could do that, but wouldn't like to unless we have to. Yeah, so my idea was basically just that we could split up the sort of where we store the device information for a host from where we store everything else. Device one, we can actually think about splitting that up into different bits because it's easy sort of to do that. You can just put a certain number of devices in one object until it reaches like that 64K limit, and then you can just have a second one. And then when we load back in the whole host cache object, we can keep track of how many of those objects there are, and this should avoid the issue. That was sort of my idea solution. Does anybody have any sort of thoughts on that? Like a good way to do that would be?
Personally, I think that's a nice natural split point.
Yeah, that's what I was sort of thinking too, because I was looking at what was in there, and there wasn't really a lot of good places to split it up. But because devices are the big thing, and because devices are easy themselves to be split up, I thought maybe that would work. I think it would require a migration, or would it? Yeah, there would be some sort of migration that would have to happen. That'd probably be the tricky part. If you're upgrading from one that didn't use this sort of device cache we're theorizing into one that did. But I think that should be possible, and it would avoid this.
Right. I mean, if you upgraded and you had some hosts only posting the old style and the new style at the same time, you'd probably need to handle that as well.
Yeah, so we had something like this when I made the agent cache object, because the agent stuff used to be in the host cache. And I had actually written the migration. We ended up removing it because eventually the idea was like because the agent had only been released in master and it wasn't in any stable release, we didn't have to worry about migrations between like unstable master branches essentially. So we ended up not having the migration there, but there was one that existed that essentially said like if you have these things in here, like we'll put them in here or whatever. And I think mostly of what it had to do was actually just removing the stuff from the old host cache. You don't have to do too much in order to get the things into the new objects. It's more of a problem of getting them out of the old one. They don't take up space there. But actually wasn't too bad from what I remember. I think it would be possible.
Yeah, one question about this question. Have you benchmarked whether this may cause an impact to the Ceph mon? Because I remember some discussions about compaction and the mon database growing, and using the mon DB for as a cache layer might aggravate this effect, right? This compaction.
What we're proposing here isn't actually caching any extra data. It's essentially just splitting it into different objects. So what we now is a host cache that we already have been using since the entirety of Ceph-EDM, as far as I know. That just stores all the host information in like an object in the Monkey store. And the idea here would be that because this object is too big on a really dense node with a lot of disk information, that we would just split the object up into like two pieces. We don't want to actually store anything extra. It was just to, I guess, have the object split into smaller pieces so that it wouldn't hit one object wouldn't hit the 64K limit.
And one other stray thought that hits me, especially for the new stuff, is did I catch you saying that this is stored as JSON?
Yeah.
So the other thing is you could consider compressing the data or something like that. You could still use JSON, but maybe even run it through something like gzip first, or minimize, remove extra space characters and stuff, then gzip. There's a couple other things you could do if you don't need this new key to be backwards compatible, or this new blob, to further reduce the risk of this happening in the future.
I don't think it would have to be backwards compatible. It just have to be that the new system would have to be able to handle ones that were set up the old way. Like if you had like one that was like an old JSON object, the new code, whatever, would have to be able to bring that back into a Python object the same way it could the new compressed one. Yeah, I guess something like that should be possible. To save a little bit more space there. Look into that as well.
Yeah, because especially if it's a streaming-friendly compression format, just doing a pipeline of deserialization, decompression to deserializing the JSON shouldn't be that much more expensive, especially if you're running low on the space.
Yeah, it's not like... Yeah, Ernesto.
Go ahead, please.
Oh, I didn't know who was talking. Hey, keep going, Redo.
It was me. It was me. Yeah, basically, it was just to ask if did we analyze all the information we are storing there to see if we need this. Basically, we don't know what kind of information is stored there. Or like storing events or something that would get grow.
It's mostly device information that we get from Ceph volume. It's possible maybe we don't need all of it. I think the reason for most of it is just for matching against drive groups, and also just reporting on disk stuff. Some users want to do like this Ceph device LS output, like stuff that's in there. A lot of what this is. And then if they also want to turn on the device enhanced scan, and that's what is quickly ended up causing this, is if they have the enhanced scan on, they get a bit more information back, and then you end up with a decent sized chunk for each device. And if you have a bunch of devices on one host, like I think this was in the DFG lab, the downstream lab, they had, I think, 20 something, 30 disks or something, I don't remember how many on one host. And then they had enhanced scan on, and so you ended up with just a large amount of information, and it ended up breaking the limit. So I mean, we already do have
30 OSDs.
Yeah, I mean, there's a lot of disks. I mean, you don't even have to have OSDs on it. It's just if you have the disks at all. We just try to gather information on the disks so that you can put OSDs on them later.
So I mean, if we have this issue only with 30 disks, then in bigger clusters, we'll have it for sure.
Yeah, I mean, and that's 30 disks on one host. If you have like a lot of hosts that all have like 10, 15 disks on them, then it would be fine. It's only right now if we have one particularly dense host. Again, that's why the idea was basically just to split up the devices into their own objects, because the problem isn't the total amount of information, it's that it's too much information in one spot, pretty much.
Yeah, I see. Okay, thank you. Maybe in this case, I think John proposal maybe a good idea to see how the much information we can save if we go with compression and the implications of that in the upgrade scenarios.
Yeah, I think I'm going to start with the splitting the thing up and then go into the compression stuff as well. I think splitting up would save more space, or it would be more like a final sort of solution for it, whereas like so compression would help, but if it was still like enough disks on there, it would still be a problem.
Yeah.
Whereas splitting it up should, in theory, cover pretty much every case. Because I don't think there's enough information that we'd ever store from a host that doesn't include disk information that it would ever overflow that 64K limit.
Okay.
And just out of my own curiosity, to riff on that idea a little, has the system ever supported like a disk being replaced on a different node? Like say node XYZ, the motherboard went bad, but you still have a disk. It might be an interesting thing if the disk was addressable uniquely, and that you could say, oh, well, disk XYZ used to be on node ABC, but now it's on a different one. It might be too exotic and outside of the normal workflow, but splitting it, again, being a natural point, you could, in theory, do stuff like in the future. Oh, it doesn't matter. This device used to be on node ABC, but now it's on node, G.
Okay. I know there's something like that for specifically OSD replacements, where if you move a disk to another host that had an OSD on it, you can do that. I don't think we've ever tried to track the disk outside of an OSD across hosts before. Again,
Okay.
the main reason for storing information, I think, as what we're concerned about, is just matching against drive group specs and everything, and then just displaying it for users.
Yeah.
So, yeah, I don't know. We haven't looked at it at all. I'm not sure the exact use case would be that we're like, oh, you move the disk to the other host, you want to know that it's exactly the same disk. If somebody really did need that, I think that would be kind of complicated, personally.
Yeah, fine. It's one of those things that, popped into my head, and I figured this was the right place to ask.
Yeah, but I don't think we do anything like that right now. And it's only for OSD replacement. If you like move the disk, I think there's some stuff for that.
Right.
But if you don't have an OSD on it or anything, then it's just a disk.
Makes sense.
Say it was there, then when it moves there, we say it was there. So.
Yeah. You probably trust the OSD metadata more than whatever random UUID or whatever comes out of the OS level anyway.
All right. Are we okay on that topic? Anyone have anything else? Okay, cool. So next we have the topic of where to put configs and keyrings. So this came up with something Rita was doing with, I think it was still cleanup, or no, bootstrap actually, the command at the end of the bootstrap. That right now we still store these things in etc. And basically the question was whether we should try to move them into varlib ceph/fsid so that they're in a spot that's very clearly linked to the fsid. This would make it easier for us to sort of infer where they are and everything. I think the point of contention was, one, the migration that might have to happen if we did that, and two, in case this was being used across different clusters. I don't think that's a common thing, and I don't think you really can for some of these things, like the key rings, I don't think so. But for the public key you're using, you technically could try to use the same one across different clusters, because you can specify when you bootstrap, like I want to use this public key, this private key for my cluster. And so the question was basically if we should try to move these over or not. We had a couple ideas in here. One was obviously just the full migration, putting everything in the varlib ceph folder instead of etc. Another was to just put it in bold spots. I kind of like this idea. The idea was because you can also, you don't always put it in Ceph, you can also like specify like an output directory when you bootstrap and where to put these keys. That if we put it there and then we also kept a copy in varlib Ceph fsid, we could still have the benefit of being able to infer those things much easier. Then also the user could have them wherever they want them at the same time, and also would require no migration. Basically, all we'd have to do is we check that spot first when we try to infer, and then if it's not there, we check the other spots, and then we just fall back to the same way we did before, basically. It's just a nice thing to have if we do have it in there. And I think there was one other. Okay, yeah, the other thing was just the question of, are there actually cases where this to be shared between clusters? And I don't think there really was, again, except for maybe the public key. So again, so my sort of idea on this was actually the idea of just supporting it in both spots. I thought that would sort of be the easiest thing to do. Have it in the FSID directory so that we know where it is, and then also leave it basically the way it was before. So just have an additional thing putting it there. And then we can do all the inferring stuff that we want to do, but we don't have to worry about migrating it. And then on new clusters, from now on, we could just put it in there to begin with, and not have it in the other spot unless the user specified one. Like if they have an output directory they send, people put it in there because they asked for it in there. But if they don't, then we'll just put it in the varlib Ceph fsid. This would require, like, we have to worry about cleaning it up and stuff, but I think it would, sort of support both cases and avoid the sort of a tricky migration of having to worry about finding these things and then moving them, which can be hard given that they can be put technically anywhere. So that's sort of the introduction on that issue and where I'm sort of standing on it. Does anybody have any thoughts on those two? Like basically just putting it in both places versus just fully migrating it or any of that, or whether we should do that at all? Yeah. I don't know, Rita, do you want to comment on it at all? I know this was sort of started with.
Yeah, I mean, and from my point of view, whenever we can put the information per cluster ID in the varlib, this would be much easier for us for all the operations from the Ceph idiom. So if we need like some code to handle the migration, and the benefits in the long run that would be higher for the effort.
Right. Yeah, it's kind of how I feel as well. It's sort of useful for us if it's in varlib Ceph fsid, because then we know which cluster it has to be attached to at all times. And we also just know that's a spot where we can look. So if we just purposely put it in there on top of the other spot, then we get all the benefits we want out of it, and then the user still has the option to put it where they want as well. We also don't have to worry about migrating.
Yeah, including the case if we give the user the option to use the output directory, I think we would be good to keep a copy of the keyring in the varlib Ceph, just in case they lose these files or they remove them by mistake or something like that. So we have a copy of these files.
Yeah, and it'll be easy to find where it is as long as you know the FSID for your cluster.
Exactly.
Right. Yeah, so I like that idea. I think it sounds like you sort of did as well.
Yeah.
Anyone have any sort of backlash against that, just having it in both spots?
Sounds good to me.
All right, cool. So that's sort of decided. I guess we'll go to the next thing. So the next two things are both about Prometheus. These are things that came from Paul Kuzner. He's interested in sort of our handling of monitoring in the Ceph clusters. And I guess I should probably actually start before we go into those two issues, because I think at least one of these, I don't remember which one, depends on actually upping the Prometheus version. There's also a tracker for increasing the version. So I guess we'll start there. So let me link that tracker. This one? Yeah, so he even gave some suggestions in here on which versions he thought would be a better idea. Now from the Ceph ADM side in our testing, like tautology and everything, we don't have a lot of testing of the monitoring daemons themselves. Like we mostly just check if we can deploy them. So I'm not really sure what a great way is to verify these are good versions to go to. But I do know what Paul said earlier is some of these other topics we have on here. I don't remember which one again, but at least one of them, I think it was actually the external Prometheus support requires Prometheus being at least version 2.23. So he's obviously recommending 2.28 in that tracker. So personally, I'm okay with having some sort of PR that tries these versions out and then maybe seeing if we can do some testing with it and if things still work. We probably have to ask around maybe what needs to be supported there, maybe just figure out what needs to be tested. But I do feel like we probably should look into maybe increasing these versions so that we can use some of the newer features like that. So, does anybody have any thoughts on that one? The versions we should swap to or any of that?
What are the implications from the point of view of testing in this case?
Yeah, that's what I'm trying to figure out. Because again, on our side, with FADM, we mostly have always just worried about can we deploy them. We don't really test too much of the actual features. I don't know. That's I guess we'd have to ask around. I think before we put something like this out, just upping them like that, the defaults. Actually, Ernesto, you're here. Do you have any ideas on maybe what we should have to check? What has to work for these to be considered valid versions?
Yeah, well, Access is now working on upgrading the monitoring stack, so probably he's going to move everything to the latest version. But,
okay.
Yeah.
You guys are looking into this stuff anyway.
Yeah.
Okay, maybe I'll ask. You said it was Ashish?
Yeah, Ashish. Yeah.
Maybe I'll try to sync up with him and I'll link him this tracker. Ask him about it. Yeah, I know the important one from Paul's point of view was getting Prometheus 2.23 at least, and he has his recommended versions on here. Maybe I can ask if going on with that. That's good to know, though. You can sync up there. Thank you. And then, so if we assume that's going to happen, then we have the other two things in here. So the first is supporting external Prometheus instances, and the idea here is that some users might have Prometheus instances that do a bunch of other things on top of just Ceph. Like they want to have one that tracks this thing and then also Ceph. But right now we don't support that at all. And so the idea behind what we have here is that we already have. Oh, I think it even says okay, it's version 2.28 actually we need to do this. Is it in that tracker? Yeah. So what is the idea here is that we already, for the agent work, we already created an endpoint for Ceph ADM. And so if we created a way to allow Prometheus, external Prometheuses to scrape that endpoint and get a Prometheus config that we've generated, then we could effectively support a external Prometheus instance.
In that case, how we handle the daemons deployment. That means that these daemons will not be handled by the Ceph ADM, or?
Yeah, so I think the way this would work is that most of the responsibility falls on whoever's managing this external Prometheus to tell it to go scrape this spot for the config. And then obviously all we have to do, all we're responsible for is just having this config available for them to grab. And then they're supposed to handle everything else. Yeah, we wouldn't be managing this one at all.
Yeah.
So in the end, it actually is sort of a simple feature. It's just that we have to be able to generate a config and have it ready at some spot in our endpoints to be able to grab.
Right now, is it already possible, like to deploy the Ceph ADM without the Prometheus?
Yeah, I mean you can just remove the Prometheus service. You don't have to have it.
Mhm.
I mean, imagine if you're doing this, you maybe could still, yeah, you probably still have to have the rest of it. You probably still have Node Exporter and the alert managers around. Maybe, I don't know, maybe the alert managers, but at least Node Exporters. I'm guessing you'd take the Prometheus config we give you, and that would tell you where the Node Exporters are so that you could go scrape them.
Do we have
That's the sort
some
of stuff we give that our Prometheus right now, is we give them like the locations and the ports and everything for the Node Exporters, things like that.
and this configuration could be consulted using the Ceph config directly, or we need to
Um,
provide some API to get this configuration for the external.
Yeah, so again, the idea here is that because we have an endpoint in Ceph-ADM, and we are also the ones who make the config, the Prometheus config, that we could just expose or have a spot on the endpoint that exposes where their Prometheus daemon could like ask eventually for the config object, and then we could give it to them, and they'll know where all of our alert managers and node exporters and everything are, or whatever it is they want that they've deployed with Ceph-ADM, and then they can use that config to scrape Ceph-ADM stuff using their Prometheus instance rather than using ours. And that allows them to have an external one that does a lot more than just looking at Ceph stuff.
Yeah.
Yeah, and so if we give this,
Sounds good. And in that case, how we ensure that the version they have is compatible with the dashboard or any other component?
again, I think that would sort of be their responsibility. We can't really control which version they deploy for their external Prometheus. I mean, because we're not controlling it, sort of by definition. I think all we can really do is give some way to support this on our side. So again, this is, I guess, yeah, you think about it that way, I guess it doesn't even really matter if our Prometheus is version 2.28, does it? Really
Yeah,
just matter.
I was just rereading the issue after trying to catch up mentally, and it does definitely feel like this is an extra thing. Like it's nice and can help newer Prometheuses. If it's there and they're using an old Prometheus and it doesn't matter, they can still manually point their scrapers at the various Ceph endpoints. It just helps, you know, if you're using the newer version, it's useful. It also implies that it's not strictly necessary to upgrade it. I get that he probably wants some good new features with this, and yes, it may simplify things, but it's not you could still add this particular endpoint somewhere and not necessarily have to use it.
Yeah, I think you're right. Yeah, yeah, because it doesn't matter what version we're using. This is only really useful for an external one anyhow. So I guess
I
we just
mean,
have
I
to on our.
think his point in the tracker issue is that it could simplify the way it's deployed with Ceph-ADM, but I think that's a maybe, and you're right. It's largely beneficial for an external one.
Yeah, I think his concern was mostly people who are deploying a bunch of different things at once. They all want monitored under a single Prometheus instance.
Right.
Yeah.
Yeah, so there's a link in that tracker to sort of what he's talking about with this HTTP config. And so I think as long as we have if we can produce sort of what this thing is looking for, the config, so that I can scrape it using this, then I think that's all we really have to do. I don't think we have to worry about our Prometheus necessarily. It'd just be essentially have this extra endpoint that you can look to for your Prometheus.
It also does make me wonder a little bit about what Rook deployed Ceph is doing for Prometheus and metrics, and if there's any potential crossover by adding something like this. That could be a common place to say, here, this is where Ceph metrics endpoints are, and it could be set up by any orchestration method.
Yeah, the only tricky thing about that is right now our endpoint is in Ceph-ADM, so if you're not using the Ceph-ADM orchestrator, then you wouldn't have this endpoint at all.
Okay.
I'm not sure exactly what Rook does for Prometheus. Blaine is in here.
Yeah.
we've been having a lot of conversations about this in the past like month or so. The short of it is that Rook is not taking ownership of Prometheus rules. Those are like, I don't know, none of the other like orchestration or like operators in the Kubernetes ecosystem deploy Prometheus rules. Like we like take it as Rook's responsibility to allow like to make sure that Rook and Ceph can be monitored so that we expose the right ports and that we do the right stuff with that, but we stop at the Prometheus rules themselves. Okay. Yeah, so I guess this feature is sort of totally independent of what Rook's doing because they don't worry about the configuring the Prometheus or anything. This will just be something we have to worry about here, which means that we can use the Ceph ADM endpoint for this will really just be a Ceph ADM sort of feature to allow supporting external Prometheus instances. I will, I guess like the reason that we have started having these conversations is that like what Rook, well, first like what Rook deploys is like a downstream only kind of solution, which happened at some point, but users do sometimes want to modify those Prometheus rules to change like the severity of an alert or like the like threshold of an alert. So considering whether you want users to be able to actually configure those alerts or not, and what sort of method would be good, we took the approach that it is like because users are used to dealing with Prometheus rules in Kubernetes and also like in Prometheus itself, it is easier just to suggest some rules for the user and have them apply them themselves with any modifications, since that's easier than writing some like override logic for those that gets kind of hairy pretty quickly. Okay.
Okay.
Yeah.
Yeah, maybe in the future there could be some overlap because I think this tracker by Paul is mainly about discovering the endpoints, not necessarily all the rules scrapers and stuff can do, but yeah, you don't need to do it now for sure.
Yeah. I mean, if anything, I feel like from a Ceph ADM point of view, what we do is have some other sort of ways to just metafy Prometheus rules that would apply to even our Prometheus instance, and then we have this endpoint here. You can maybe pick that up with your external one. So it would affect both of them because just so it should be really generating the config in the same way. It's really just we need to expose the config on this endpoint. So I think for the time being, if we want to look into this, it would really just be about exposing this config, mostly with just the endpoints that the Prometheus needs to look for to an external or to an externally available endpoint. And from there, we can move on, we add other things as people decide they need them. Yeah, and again, I think what as John mentioned earlier, needing the version for us is really just about if we want to make use of it ourselves. I don't think there's any need for us to do so right now, maybe in the future. So yeah, I don't really want to worry about that at the time because we already have a working way of doing it. But we can also just have this available. So if somebody does want to have some solution that includes Prometheus, that's an external one, they can also do that. So those are my thoughts on it. Anybody have anything else they want to sort of say on this one? No. All right. We'll move on to the last topic on here, which is just also Prometheus. This one is a bit more interesting. This one I'm less sure. Oh, Sebastian commented on it. Interesting. Yeah. So I guess to start off the conversation, Sebastian came back to comment on this tracker, and he says that he's against it. So start there. But anyway, the idea was what Paul was thinking is he was talking about doing HA for Prometheus. And his sort of idea for it was that right now, when we deploy Prometheus, we have sort of their config, and it's like just on the file system of the host, whatever host we deployed it on. And so if we have multiple instances or anything, then they have to sort of like sync those up. Or if you modify one of them, then like the new one won't have it or anything like that. So what he wanted to do is have an RBD image, and then have Prometheus store all of its like files and data and everything in this image. And then if we did that, then any Prometheus daemon that gets deployed would always sort of be using the exact same stuff. And that way we could just, one goes down, we just put another one down. It wouldn't matter. It'd always, have the same stuff. So you essentially could have HA in that form. So I'll immediately go into what Sebastian sort of brought up as issues with this. I think the second one is the one that makes more sense to me, which is that an RBD image, if your cluster is actually having serious issues, that could be what's going down. And that's sort of the situation in which the monitoring could be the most important. And so you wouldn't be able to use the monitoring, I guess, when you most want to, if you did it this way, because you're kind of making it depend on the cluster itself. And then the other problem is, and I'm not much of a Prometheus expert, so I'm not sure exactly what this means, but Prometheus instances are supposed to scrape targets independent of each other. So I guess if you have multiple Prometheus instances, you actually don't maybe want them to do that. I'm not sure how big of a deal that is personally, because in this specific case, we're talking about Prometheus instances that are just meant for HA. So they would probably be meant to scrape the same things. But at least the second point of that I think makes a lot of sense, which is that you are making Prometheus now depend on sort of cluster availability in order to function. And that might not be the best choice for your monitoring stuff, to have it go down whenever everything else does, then you can't tell what's happening.
Yeah, I'll add one more question mark to that list, which is what mechanism would this container be expected to access the RBD volume? Does it have to go through a kernel module, the RBD kernel module? Would it be expected to have some sort of plugin to talk to the RBD volume directly? This comes up from my downstream OCS. I can't even figure out how to not call it by downstream name. These conversations about what's the best way, when you're containerized, having a dependency on the kernel can be a little bit of a funny situation. So I know people have been looking into things like RBD, NBD.
Yeah, I mean, that's sort of the type of concerns I had originally when I looked at this, which was that it's just, there's a lot of things that make it tricky to implement. It's sort of not normal for us to do this, to have deployed daemons that write things into images like this. Usually it's always like some user specifically said, I want to write something into an image. We don't usually just say like, oh, we're going to just do that on our own.
How much data normally this service writes a disk? Is it a lot of data?
I'm not really sure what the volume of data that it actually puts down is. I'd have to ask Paul. Because he's been testing this sort of stuff at scale. I can tell you at his sort of scale testing, he's been using Prometheus to sort of monitor a lot of things. And I know there were some issues with how many metrics it was pulling from various places, but I don't know how much it actually like writes and how much it stores at any given time. So we have to look at that as well. Because we obviously don't want to put a ton of data on there. I mean, to be fair, if it is a lot of data anyway, then we're still just putting that on the host file system instead of just in an image. It's not like it's not taking up space. But still, we don't really want to be filling up our cluster with a bunch of random monitoring data, especially unless the user didn't specifically ask for that anyway.
And then there's always the perennial question of like, where's my storage going? Oh, it's all towards our own metadata. Sometimes it's unavoidable, but the question does come up for people to say, oh, you're using 2% of my storage already for stuff I didn't ask you to do specifically.
Yeah.
Yeah. So sounds like people, including me, are sort of tentative in this one.
Yeah, especially the second point, I think is very important. If we are storing data that we need for monitoring in the cluster itself, if something is wrong with the cluster, then like the
If it was just configuration, it might be slightly more interesting, and then you
Yeah.
could probably even avoid doing it in RBD. You could possibly use something lower level. But since he does call out configuration and data,
Yeah.
I think that makes it a lot trickier.
If it were only configuration, something like you read during the startup once, and then you like to keep it in sync between all the instances in the cluster, that would make sense. But to write the monitoring data itself, I think very risky to use the cluster for that.
Yeah. On the other hand, it's always nice to say like, oh well, we have this wonderful distributed replicated storage system right here. Why not use it? But yeah, between the complexity possibility and Sebastian's point about do you really want everything to rely on this? You could probably think of ways to do it. Like you could, I don't know, write 2 copies, one to a local file system, one to an RVD, blah, blah, blah. But again, you're just ranking up that complexity. It feels like, more thought is required before we jump onto a solution like that. It's clever and I like it, but yeah.
And in that case, probably the idea would be like to create some dedicated pool to this kind of data to have it separated from the rest of the data.
This would also mess with the fact that normally what we do when you bootstrap, unless you typically tell us not to, is we deploy a monitoring stack. And obviously you can't do that because you have no OSDs at that point. There's nowhere to put a RBD image. This would also make Prometheus dependent on sort of us already having that stuff set up beforehand.
Yeah. And the other point, maybe just for ignorance, I don't know what will be like the benefits in practice of having this data like centralized. I don't know, like if like later they have some tools to read this data and to present it somehow. Then it makes sense to have it centralized to access all the data in the same location.
Yeah.
I think we have some more information to understand. But what is like the practical benefits of this feature, so we can make a wiser decision.
As far as I know, it was really just his idea of one way to implement Prometheus HA. And it's not even the only idea. There were some other ones that people proposed, and this was sort of Paul's proposal, but I think you all see here that there's maybe some issues with it. Ernesto just mentioned another one in the chat. Sometimes you want to block writes, and if you block writes on your cluster, then you now blocked all monitoring Prometheus. So a lot of things that could go wrong with this.
Yeah.
Maybe I'll have to have a chat with him about it and tell him, bring up this stuff, and maybe see if we can look into some of the other HA options.
Yep.
All right, that's good. We had that discussion. That was the last topic I had on the agenda. So does anyone have anything else you want to talk about? We have like 10 minutes. No? All right, if not, we can end it here, and I will see you all next week. Bye.
Great. Goodbye.
Thanks, bye.